Hello and welcome back to the Cracking FAANG YouTube channel. Today we're going to be solving Leetcode problem 827, making a large island. Before we get into this problem, I just want to say if you haven't watched my videos on either max area of an island or number of islands, please go watch those videos. We're going to be using some of the same techniques to solve this question that we used to solve that one, and if you don't know how to solve those, you definitely won't know how to solve this one, so please go back and watch those first because they lay the foundation of how to solve this problem. This problem is labeled hard on Leetcode, and you're going to need some of the principles that we learned in the mediums that use the same topic to actually solve this one. So that being said, let's get into the question prompt. You are given an n by n binary matrix grid. You are allowed to change at most one 0 to be a 1. Return the size of the largest island in the grid after applying this operation. An island is a four-directionally connected group of ones. So for example, if we have this island here, we have this grid here, right? And we can see that there's one island currently, and it's the island, with these two tiles. So what's the largest area if we could flip 1 0 to a 1? Well, we could see that if we flipped either of the zeros, we'd get an island of size 3, right? If we made this a 1, then we'd get a size 3. So the answer here is 3. And, it seems quite simple how to do this if you're looking at the grid, but how to do this programmatically is a little bit tricky. So the naive solution would be to simply go throughout the grid. Every time you see a 0, transform it to a 1, and then kick off a depth-first search in all four directions to basically count the number of islands adjacent to it, similar to how we did max area of an island, and then add that up and then keep a result going as we go. The problem with this solution though is that you're going to end up recomputing the areas for multiple islands. For example, if you were to do this here, you'd compute the area of this island, which is here, but then when you get here, you'd be recomputing that. So unless you did some sort of memoization, you would actually essentially end up repeating a lot of calculations, which we don't want to do. What we want to do is actually pre-compute the areas of each island. And the thing is, we don't want to count an island multiple times, right? Because if we say, okay, well, if we're at this 0 here and we flip it to a 1 and we go to the left and then our DFS is going to go in all four directions, we will accidentally count this island twice, right? We'll go here and it's going to count this entire island if we do a DFS. But then when we go down as part of our original DFS, we'll get here and that will DFS into the top one and we'll actually count it twice. So we have to have some mechanism to actually count our islands in a unique way. So what we're going to do for this problem is actually we're going to do one iteration through our entire grid just to figure out the distinct number of islands. And what I mean by this is, let's say we have a bigger grid here and we'll kind of just draw it out. And let's say we have an island up here, we have some 0, we have an island here. So this is an island, this is an island, and then maybe there's an island over here, right? These are all distinct islands. Let me just change my color. So this is going to be an island, this is going to be an island, and this is going to be an island. What we want to do when we go through our first iteration here is actually to change all of these ones to whatever the island ID is. And we're going to start the island ID at 2. And the reason we want to start it at 2 is that way we don't end up overwriting characters that we've already used. We can use 2, or we could use something like -1 and then go to like -2. That way we make sure that we don't actually end up writing a value that's already in the grid. So for example, let's say we started with, -1 as our island ID. So we'd start here at the top left and we'd see that this is an island because it's a 1. So we're going to set all of the tiles that this island touches to be equal to -1. And so we're going to set this equal to -1. And now that our DFS finishes here and we found this island, we can then move on to island ID -2. So the next island we see, we're going to set all of the values of that island to be -2. So we keep going, traversing over our grid to find all the islands, and we get to this one now, right? So we're going to set its value to -2, and again, we're going to try to kick off our DFS in all four directions, but we can see that there's actually no more islands here. So that means that this is the only one in the island with ID -2. And what we're going to do is we're going to have a dictionary which maps the island ID to the actual area of the island. So this one was area 2. We have island with ID -2 and its area is 1. And then we'll see that, now our ID is going to be -3. and we're gonna have this island of area 2. So now we set these equal to -3, -3. So now we have -3 and 2. So the reason that we want to do this is, I guess, when we go through for a second time and we get to a 0, now we don't actually have to DFS into our surrounding tiles to figure out the area of those islands. We can simply say, okay, well, you know, we start at this 0, we're going to flip it into a 1, and we need to figure out the area of the islands that would be formed if this was a 1. So what we need to do is basically, is there an island to the left of me? If yes, I want to add its area to my current area, which is 1. Is there an island to the top of me? If yes, and I haven't seen that island, because it could be the case that this is also, you know, -1. So that's why we have these set to -1. So we can maintain a set of all the islands that we've taken points from to make sure that we don't have duplicates, because we don't want to count the area of an island multiple times. So for example, when we go left, we want to take the area of islands with an ID of -1. Then we go to the right, we can see that there's an island with -2 ID. So we get its area, which is 1. And then obviously -1 was 2. Then when we go down, we can see that there's no island here, and we go up. Obviously, this is outside of the grid, so that's not valid. So we would want to add the area that we get from flipping this 0 to a 1. So that's going to be 1 plus the area of the island -1, which was next to our, you know, point that we just flipped. So we add the 2, and then the area of the island with ID -2, which was to the right of our current island. So that means our new island would be this big one here that we form, and it's of ID 4. And this is going to enable us to basically not have to do the DFS each time to calculate the area, because we've pre-calculated it, we've stored it here, and we can essentially just reuse the computation. But remember, we have to keep track of the islands that are next to us with a set, because we don't want to accidentally count an island multiple times in the case that it actually has, like, for example, if this tile here was -1, then we would count this as the area here, but this already includes it. And then if we went down, we accidentally double count it. So that's why we want the set here to make sure that we only count islands one time. So this drawing is getting pretty much into like a bowl of spaghetti here. It's getting really messy. And I think at this point, what I want to do is actually transition into the code editor, where we're going to type this out, go through it line by line, and hopefully it should be a whole lot more clear, because it is a little bit confusing to look at the example, especially with all of the kind of squiggles going on. So let's stop this here. Let's go to the code editor and write this up. It's really not that bad of a problem. It is quite a bit of code, but it's not really that complicated. You should know how to do this from those previous problems that I told you should know how to solve before trying this one. Anyway, that's enough rambling for real. Let's go to the code editor. Okay. We're in the code editor. Let's code this up. Remember that I told you that we want to have an island ID, which is going to keep track of each individual island, so that way we can overwrite its value in the grid, and that way when we go back for a second time, we can actually know which island we're working on in a really quick way. So let's say that self.islandID is going to start at -1, because we don't want any clashes with the values that are already in the grid, which are 0 and 1. So obviously we don't want to start it at 0, we don't want to start it at 1, because that's going to make problems for us. And we also need a dictionary, which is going to map the island ID to its area. So we're going to say self.islandAreas is going to equal to just an empty dictionary. And this is one of those grid problems where we're kicking off a depth first search in 4 directions. So we need to define our directions. So we're going to say self.directions, and pretty standard, we're going to have our 4 directions here. So let's just code these out. And those are the 4 directions we can travel in. Now, what we need to do, remember, for the first iteration through our grid, what we want to do is go through and find the area of each island, set its tile values to whatever the current island ID is, and then at the end, update our island areas with the total area of our island. And remember that essentially, this is the same process that we did in the problem finding the area of an island, right? So let's do it. We're going to say for m in range, range len grid. We're going to say for n in range len grid of m. We're going to say, okay, if the current value is a 1, that means it's an island value. So that means that we want to kick off our DFS here. So we're going to say if grid of m comma n equals a 1, that means that this is a new island that we're visiting. We want to find all of its tiles. So we're going to say island area is going to be equal to our DFS function, which we'll write in a second. And the DFS function is going to take our grid, and it's going to take our current m and n position. And now that we have the island area, we want to put that into our dictionary. So we're going to say self.island areas of, let's see, self.island ID is going to equal to the island area, island area. And then we want to basically now increment our island ID. Although because we're using negatives, we're actually just going to decrement it. So we're going to say self.island ID, we're going to decrement it by 1. So now we have a new unique ID for the next time we go through our thing here. So at this point in our function, we're actually going to have all of the areas for each of the islands, and their values will be overwritten inside of the DFS function, which we'll write in a second. So now what we want to do is we want to define our answer, which is going to be max area. And what we need to do is go through for a second time and basically flip each 0 to a 1 and figure out the maximum area we can get by essentially doing that. So let's go through the grid one more time. We're going to say for m in range len grid. We're going to say for n in range len grid of m. We're going to say, okay, if the current position is actually a 0, then we want to flip it to a 1 and figure out what the maximum area is if we were to do that. So we're going to say if not grid of mn, so essentially if our current value is a 0, we're going to say the area is 1 because that 0 flips into a 1, so that is at least an island of area 1. And then we want to keep track of all of the distinct surrounding islands touching that current position. It could be the case that, you know, to our left and, you know, above us, so up and to the left of us in the grid is actually the same island. So we only want to count it once because we're going to add the area of that island, and we don't want to count it twice. So we're going to say surrounding is going to equal to a set. And now what we want to do is look in all 4 directions, figure out all the distinct islands 4 directionally, and add their areas to us. So we're going to say for m increment n increment in self.directions. What we want to do is we want to say that the new m is going to equal to m plus the increment of m, so m increment, m inc, and we're going to say the new n equals to the old n plus n increment. And now what we want to do is we want to check, first of all, is our new m and n combination, so the new row and column, is it inside of the grid? Obviously we don't want an index error, and we want to make sure that the new row and column position, the value there isn't actually a 0, because if it's a 0, we don't care. It's not an island. We can't take its value. So what we want to do is we want to check that. So we want to say if the new position, so we want to make sure we're in the grid. So we're going to say new m less than len grid, and we're going to say the new n is also less than len grid 0. So that's going to check the columns. And we want to make sure that grid, let me just move this over so we can have some more space here. Grid of new m, new n does not equal to 0. So we want to make sure that the new value at that index, new m, new n, is actually an island. If it's not, then we don't care about it. So we're going to say surrounding dot add grid of whatever new m and new n is. Remember that we don't want to be double counting things because then we're going to get the wrong answer. We only want to sum the areas of the distinct islands that are touching our current position. Cool, so now we've done that, and now we need to actually add those areas, because all we did was actually just add the IDs of the surrounding areas. Remember that we overwrote the grid position at that index with the island ID. So now we know all the IDs that are neighboring us because they're in the surrounding set. And now what we can do is actually just add them to our area, which remember is just 1, because all we've done so far is flip that 0 into a 1. So what we want to do now is we're going to say for island ID in surrounding, all we want to do is add to our current area the value from the island areas dictionary for whatever that island ID is, and that's going to be the area of the island that we can form by flipping our current position, which is a 0, into a 1. Now all we need to do is simply check that this is a maximum. So we just want to say max area, which is the variable storing our solution. We just want to take the maximum of whatever its current value is and our new area. And if our area is greater, then obviously that becomes the new best answer. So once we do this process for every single 0 in our grid, what we want to do is actually return our answer. Now, here's where an interesting edge case comes up. What happens when the entire grid is 1s? Well, if the entire grid is 1, we'll never actually hit this point here, and we'll never actually end up updating our max area, because the only time this if statement fires is when we're at a position in the grid that's 0. If the entire grid is an island, in this case here, then we would actually just return 0, because max area currently returns 0. So what we need to do is check, actually, have we seen an island? Because if we haven't seen an island, if our max area is still 0 at the end of this double for loop, that means that the entire grid is actually an island. And in that case, we don't want to return 0. Obviously, that's the wrong answer. We just want to return the dimensions of our grid. And remember, it's an n by n matrix, so we just want to return, n squared. That's going to be our solution. So that's the last thing we have to check. We're going to say return max area if basically max area is non-zero, right? Otherwise, we just want to return the length of the grid squared. And remember, the grid is n by n, so it's just length of the grid squared. And that's going to be our final solution there. So that being said, we still need to define the DFS function, which is actually going to calculate the area. So we're just going to do this quite quickly, because you should already know how to do this from the previous max area of an island. So we have our grid, we have our m position, we have our n position, and essentially what we want to do is we just want to find sum all the areas of all the adjacent points that are part of our current island. So what we want to do is we want to basically just check that we're even in the bounds of our grid so far. So we're going to say if 0 less than or equal to m less than or equal to grid. And so that basically checks the rows, and we want to check the columns here. So n less than len grid of m. And basically the last thing that we want to do is we just want to make sure that we're actually at a an island value, right? If our current position is actually a 0, that means it's water, and that isn't a valid position, so we just want to exit out of our DFS here, because we don't want to be summing anything here. If it's water, we don't sum it. So we just want to make sure that grid of m comma n actually equals to 1, which is land. In this case, what we want to do is, remember, we want to overwrite the current value with whatever self the island ID is. And what we want to do is we want to say area equals 1, and then we just want to go forward directionally and figure out what the area is by basically applying our DFS function to the 4 adjacent tiles to us. So we're going to say for m increment n increment in self.directions. What we want to do is we want to say area plus equals to self.dfs grid m plus m increment n plus n increment, and at this point all we want to do is return the area. And then for the if statement, basically if we're outside of the bounds of the grid or our current position is water, then all we want to do is return 0, because that's not going to affect our answer. Obviously adding 0 to anything just returns whatever you added that 0 to. So that is the DFS function. This is where we called it in here in the initial pass through of our loop here. So let me just run this, make sure I haven't made any syntax errors, because obviously this is quite a lot of code. It looks like it's running. Let me just submit it. Hopefully I didn't waste 5 minutes of my life typing this. And after this problem goes, it's quite a large example test cases. Hopefully this runs. Okay, cool. It ran. Perfect. So last thing that we need to do is talk about the time and space complexity here. So what is the time and space complexity of our algorithm? Well, what is the worst case here? So in the first example, we basically go over every single tile in our grid. So doing that is going to take big O of n squared time. Now we go through it a second time, which is going to also take, big O of n squared time. And the reason for this is because we could have the worst case where actually all of the grid is actually ones. So we would basically kick off our DFS from the top left, and we'd have to touch every single position once in the grid as part of the DFS. So we're going to end up doing 2 times, so basically it'd be big O of n squared, and then the second pass through is also going to be big O of n squared, where n is the, dimensions of our grid. So n squared, because obviously it's an m by n matrix, so there's n squared values in our grid. So our time complexity is, asymptotically just going to be big O of n squared. Space complexity wise, in the worst case, there's going to be half the grid is going to be zeros and half the grid is going to be ones. In this case, we basically have to store big O of n squared over 2 islands. So in this case, half of the grid would be, distinct islands. And then the other half would be water, so we'd end up storing n squared over 2 grids in our self.island areas here. So because of that, our space complexity is also going to be big O of n squared. So that is how you solve making a large island. I think this problem is quite cool. It uses a lot of the concepts that you learn in other medium level questions, and I think this is definitely a fair question for the hard, because it basically requires you to think about how you might abstract away that recomputed part by using some sort of like memoization, which we do here with the island areas, and then simply just checking the ID of the surrounding area, and that way we can just add the area very quickly because we've pre-computed it in our first pass through. So that's why this question is a hard one, although not the most difficult hard. I think it's relatively straightforward, especially once you see a video like this. I was having a lot of trouble solving this question at first, but then I saw a video with an algorithm very similar to this, and it just absolutely made everything click, and hopefully the same thing happens for you. Anyway, I'm going to stop rambling because this video is probably 20 minutes long. If you enjoyed the video, please leave a like and a comment. It really helps with the YouTube algorithm. If you want to see more content like this, please subscribe to the channel. I have a ton of videos helping you solve these LeetCode questions, and I plan to make a whole ton more, so please subscribe so you don't miss future videos. Otherwise, thank you so much for watching this video, and have a nice rest of your day.